In this question, you're being asked to give the expected major product or products of the following reaction. If there is no reaction taking place, write no reaction. All right, so again, we're in lecture 14. We're on the topic of SN2. So right now, we really only need to evaluate SN2 reactions, but you'll see later on we'll start to need to evaluate other side reactions as well. But we know this is going to be some sort of SN2 since that's where we are if a reaction is going to take place. All right, so let's just go through the steps. Let's evaluate everything. Again, I like to start with the substrate, and I find the substrate by looking for that leaving group. So I'm looking at these species, and I'm looking for a good leaving group on something. And right away, I notice this species right here. It's a very large species. Does it have a good leaving group? It actually does. It's not a halogen in this case, but it's something else. It's some sort of resonance stabilized leaving group. And that's usually one of those sulfur derivatives. So here I redrew that sulfur derivative. I'm just showing the bond right here because that's going to be an important bond here. So the leaving group on this species is this whole portion from this oxygen over. It's the oxygen that's actually going to leave this carbon right here. These electrons are going to leave on this oxygen. So that oxygen is going to have a full negative charge. But that negative charge is going to be resonance stabilized among all of these atoms here. And that's going to make it, that's going to stabilize it. And if it's more stable, it's a better leaving group. We also have to keep in mind that this oxygen is pulling electron density from this carbon, which I'm going to put in red, which means that carbon is getting a buildup of positive charge. And if it's getting a buildup of positive charge, it's going to be susceptible to attacks by nucleophiles. So now we're just going to look and see, do we have a nucleophilic species in here? Well, remember, nucleophiles typically have electrons that can be donated, whether they have a full positive, a full negative charge, or just lone pairs of electrons. In this example, we have something with a full negative charge, this species right here. And remember, there is some cation in there, it's just not drawn in. And this is dissolved in ether. So this is a great SN2 reaction. Plus, this substrate is primary, so it's excellent for SN2. So what's actually going to happen here? Let's just redraw this species. These lone electrons are going to attack this red carbon right there because that is the positively charged carbon. That is going to kick out these electrons because remember, carbon can only have 4 things bonded to it. So something has to go, and the best thing to go is that leaving group. Draw this arrow coming down this way. That means we're going to end up forming this species right here. And here's that new bond. I'll redraw this carbon as red. Here's that new bond. And this is the species that we're actually interested in. That is what formed. The other thing that formed was just the leaving group, which I'll draw in here. And that is the oxygen holding that negative charge. And remember, that negative charge, it's delocalized among all of these atoms right here. And that would be the product of this reaction.